class, this is Professor Latham, and I'm going to be doing a movie on hypothesis tests for the correlation coefficient and the slope of the least squares regression line. So we have a problem here with Newburgh Park, Florida. It's a popular beach resort town, and property values are fairly high there, and as such are rather well studied. One topic of study has been the relationship between the housing prices and distance from the beach. For a recent sample of 16 houses sold in Newburgh Park in the past year, the value of the sample correlation coefficient R relating the variable house price and distance from the beach was negative 0.36. We want to test for a significant linear relationship between the two variables by doing a hypothesis test regarding the population correlation coefficient ρ. Assume that the two variables have a bivariate normal distribution and use the 0.05 level of significance and perform a two-tailed test. Then fill in the table below. So we're testing if the relationship is significant, and so we're testing whether ρ is equal to 0 or ρ different from 0. If ρ is equal to 0, then you're saying that the relationship, there is none. If ρ is different from 0, that's the same as saying it's significant. So different from 0 means that it's not just a bunch of scattered dots, that there's a relationship between them and that the relationship is linear. All right, so let's go ahead and use our test statistic. It's going to be t. And the degrees of freedom is going to be 2 less, one for each of the each of the variables. The bivariate normal distribution, bi meaning 2. So we're going to do the degrees of freedom, which is the sample size less 2. So it's going to be 16, because that's the sample size, less 2, which is 14. And then to find the test statistic, if we go to list of formulas, then we'll have a formula for inference for correlation and regression. And if we click on that formula, it's r times the square root of n minus 2, 1 minus r squared. I'm not sure if you can see that. But when you click on it, it automatically transfers the value to the calculator. And so we have here that our r value is negative 0.36. N is 16. And notice that the top of this equation, 16 minus 2, is also the degrees of freedom. That can be a check for you. And then minus 0.36. And since it's negative, I'm going to put it in parentheses. And that will give me a test statistic of negative 1.44, and they tell us to round it to 3 decimal places, so I'm going to go to the 4th decimal place, which is 8, and then since 8 is larger than 5, I'll round up to negative 1.444. To find the p-value, we want to find what's the probability that t is going to be to the right of positive 1.44. So let me select this calculator key. So I want values to the right of positive 1.44 or values to the left of negative 1.44. Well, since the calculator key only does values to the right of positive numbers, well, it does the values to the right, period. I'm going to change this value here from a negative to a positive. Oh, dear. So I'm going to find the probability that t is greater than, but not the negative, the positive. I don't know if it'll let me erase just the minus. It won't. That is such a bummer. And the degrees of freedom is 14, so I'll just have to put in 1.44. What if I put a minus sign in front of it? It'll let me do that. Let's see what happens. And then we're going to multiply that number times 2, and you get 0.1707, or 0.171. So what I did was, even though this value was negative, I noticed that because of symmetry, if I look at the t-distribution, the student t-distribution, different shapes of bells, and then what we observed for this distribution is that because of the symmetry, being to the right of 1.444 is equivalent to being to the left of negative 1.44. And since this calculator button always does values to the right of a positive number, because we want the numbers in the tail, then if I double that value, I'll have my p-value. So let's clear this out so you can see that again. So you can put 2 times the probability of t, whatever this value is. If it's positive, just leave it alone. And then degrees of freedom 14. And that helps you find the p-value. So you get 0.171. So since the p-value, this is always the test you're going to do. So write this down on your paper. P-value less than alpha. And so we asked that question, is 0.171 less than 0.05? And you say, well, Donna, where'd you get the 0.05? Well, if you scroll up, they said to test this test at the 0.05 level of significance. So that's why I know that less than 0.05. So I have on my paper 0.171 less than 0.05. And that's false. 17 cents is not less than 5 cents. So since that's false, then my decision is do not reject H naught. So do not reject H naught. I'm really kind of saying I believe it's okay. I'm not in favor of H1. So if you're not in favor of H1, then you're basically saying no, that it's not significant. Okay, so I hope that helps, and I'll do another one where they might have the critical values. All right, thank you. Bye-bye.